Hello, and welcome to this lesson on state symbols in chemical equations. Today, we will focus on understanding how to read and use state symbols in chemical equations where appropriate. By the end of this lesson, you will be able to identify and apply state symbols to represent the physical states of substances in chemical reactions accurately. So far, we've talked about the three states of matter: solids, liquids, and gases. You've also learned about the processes by which a substance changes state, such as melting, boiling, freezing, and condensing. Additionally, you are familiar with element symbols and how to write chemical equations. Building on this foundation, today's lesson will enhance our chemical understanding by introducing state symbols. In a chemical equation, it is useful to make the state of reactants and products clear. This is done using state symbols. These symbols tell us if a substance is in the solid, liquid, gas, or aqueous state. The state symbols are S for solid, L for liquid, G for gas, and AQ for aqueous, which means dissolved in water. Let's look at each of these state symbols more closely. The solid state, represented by the letter S, is shown here. When a substance is in the solid state, its particles are closely packed together in a fixed orderly arrangement. For example, sodium metal, Na, is a solid and is represented as NaS in a chemical equation. The liquid state, represented by the letter L, is shown here. In the liquid state, particles are still close together but can move past one another. For example, water in its liquid form is represented as H2OL. The gas state, represented by the letter G, is shown here. In the gas state, particles are far apart and move freely in all directions. For example, chlorine gas is represented as Cl2G in a chemical equation. The aqueous state is represented by the letters Aq. A substance is in the aqueous state if it is dissolved in water. For example, hydrochloric acid, dissolved in water, is represented as HClAq. Now let's explore two examples to help illustrate how state symbols are used in chemical equations. When solid sodium reacts with chlorine gas to form solid sodium chloride, the equation is 2NaS plus Cl2G turns into 2NaClS. Example 2. When solid calcium carbonate reacts with hydrochloric acid dissolved in water, forming calcium chloride dissolved in water, and carbon dioxide gas, the equation is as follows. Let's dive into some GCSE level questions to apply our understanding of state symbols in chemical equations. Our first question is, write the balanced chemical equation for the combustion of methane in oxygen to form water and carbon dioxide, and include the appropriate state symbols. The balanced chemical equation with state symbols is shown here. Here, methane, CH4, and oxygen, O2, are both gases, indicated by G. The products, carbon dioxide, CO2, and water vapor, H2O, are also in the gas state, hence the G symbol. If you're unsure how to balance the equation, so are not sure why there is a 2 in front of the O2 and H2O in this case, then make sure to revisit the lesson earlier in the course on balancing equations. Question 2. Write the chemical equation for the neutralization reaction between aqueous hydrochloric acid and aqueous sodium hydroxide to form water and aqueous sodium chloride, including the appropriate state symbols. The chemical equation is written here. Hydrochloric acid, HCl, and sodium hydroxide, NaOH, are both aqueous, indicated by Aq. The product, sodium chloride, NaCl, is also in the aqueous state since it is soluble, and water, H2O, is in the liquid state, indicated by L. Question 3. Write the balanced chemical equation for the thermal decomposition of calcium carbonate to form calcium oxide and carbon dioxide, including the appropriate state symbols. The balanced chemical equation with state symbols is CaCO3S becomes CaOS plus CO2G. Here, calcium carbonate, CaCO3, is a solid, indicated by S. The products are calcium oxide, CaO, which is also a solid, and carbon dioxide, CO2, a gas. In each of these examples, we've applied state symbols to clearly indicate the physical states of the reactants and products. This practice not only provides a complete picture of the chemical reaction, but also helps in understanding the context in which these substances interact. In today's lesson, we focused on understanding and using state symbols in chemical equations to represent the physical states of substances. We began by revisiting the three states of matter: solids, liquids, and gases, and introduced an additional state, aqueous, which means dissolved in water. We then examined the state symbols: S for solid, L for liquid, G for gas, and AQ for aqueous, discussing how they provide essential information about the physical states of reactants and products in chemical reactions. To illustrate the practical application of these symbols, we explored two examples of chemical equations. The first example showed the reaction between solid sodium and chlorine gas to form solid sodium chloride. The second example demonstrated the reaction between solid calcium carbonate and aqueous hydrochloric acid, producing aqueous calcium chloride, liquid water, and carbon dioxide gas. Finally, we had a deeper look into various practice GCSE questions.